Welcome to today's Explainer. I'm so glad you're here, because we're about to dive into something literally happening right outside your window, right now. We're talking about daylight, but more specifically, how daylight intensity varies daily in ways that are actually kind of violent. We'll look at these massive daily fluctuations in natural light and the absolutely ingenious ways science tries to capture and standardize the chaos. If you've ever wondered how industries make sure a red car looks the exact same under the blazing sun as it does in a showroom, you are absolutely in the right place.
Okay, let's dive into this. Our roadmap for today is pretty straightforward. We'll start by defining true daylight, then look at daily variations in intensity, move on to comparing day and night, discuss the need for standards, and finally wrap up with D65, simulating the sun. I promise, the barrage of numbers early on builds to a really fascinating scientific solution.
All right, kicking things off with Section 1, defining true daylight. And spoiler alert, it's more than just sunlight.
So daylight is pretty much a constant, right? It's illuminating slightly more than 50% of the Earth at any given second. But what exactly is it, scientifically speaking? Well, it's defined as the combination of all direct and indirect sunlight during the daytime. That means it's the harsh, direct beams hitting you in the face, sure, but it's also the diffuse radiation from the sky and even the light bouncing back up off the ground and buildings. But here's a fun little quirk for you. Even though moonlight is technically just indirect sunlight reflecting off the moon, daylight strictly excludes moonlight. Go figure. Moving right along to Section 2, daily variations in intensity, or as I like to call it, the extremes. You see, the sun doesn't just switch on and off like a lamp in your living room. Its illumination shifts drastically based on weather, geography, and the time of day. Consider this number, 120,000 lux. Now, lux is just the unit we use to measure illuminance. When you step outside into the absolute brightest, most direct sunlight at exactly noon, you are getting bombarded by up to 120,000 lux. To put that into perspective, that level of natural light is so incredibly intense, it can literally cause physical pain to the human eye. It's blinding. But now, contrast that extreme high with this one, less than 200 lux. And here's the kicker. That 120,000 lux was at midday, right? Well, this under 200 number is also measured at midday. How? Well, this is the extreme low you get when the midday sky is just completely smothered by thick storm clouds. The way daylight intensity varies daily is wild. It can swing in a matter of hours or even minutes, dropping from eye-watering brightness to a gloom that barely registers, all because of changing atmospheric conditions.
Now, what's really interesting is the journey the light takes throughout the day. We start at bright sunlight around 111,000 lux. Just stepping into the shade at midday under a clear sky plunges you down to 20,000. A typical overcast day drops you to the 1 or 2,000 range. But as the Earth rotates and we hit sunrise or sunset on a clear day, the ambient illumination is just 400 lux. Throw some clouds over that sunset and the intensity plummets to a mere 40 lux. The sheer scale of how daylight intensity varies daily from dawn to dusk is just staggering. Which brings us perfectly to Section 3, comparing day and night and where those lines get incredibly blurred. Because daylight intensity varies so wildly, the mathematical dividing line between daytime and nighttime brightness can almost vanish entirely. Think about it. If you have super thick storm clouds rolling in exactly at sunset or sunrise, daylight intensity can drop to less than 1 lux, literally less than a single lux. It can get so dark during the day that distant streetlights will actually cast visible shadows. Meanwhile, a full moon on a totally clear night produces about 0.25 lux, so a stormy daytime sunset is barely brighter than a clear moonlit night. And that's not even counting the really extreme stuff. Introduce heavy smoke, thick dust, volcanic ash, or a solar eclipse, and daytime can absolutely become darker than a moonlit night.
So here's the million-dollar question. If daylight is constantly shifting like this based on time of day, season, and weather, swinging wildly from 120,000 lux all the way down to less than 1, how do we ever measure or agree on color? If you manufacture anything, how do you actually know what color it truly is if the natural light outside is changing every 5 minutes? That leads us to our solution in Section 4, the need for standards, taming the light. To solve this massive headache of constantly shifting daylight, industries turn to the International Commission on Illumination, or the CIE, and they solve this by creating something called a standard illuminant. Simply put, a standard illuminant is a theoretical source of visible light with a published spectral power distribution. it gives us a mathematical baseline. This is exactly how global industries guarantee color consistency across the board. Instead of relying on the chaotic, unpredictable sun outside, they rely on a strict, published profile of light to make sure the image on your screen or the paint you're buying looks exactly the way it was intended to.
And the CIE's approach is incredibly comprehensive. Starting way back in 1931, they mapped out these different theoretical light sources. Illuminant A represented your typical domestic tungsten lighting. Illuminant B was direct sunlight, and C was average daylight. Later on, they rolled out the D series to specifically map variations of daylight, the E illuminant for equal energy, and the F series for fluorescent lamps. They basically categorized, tagged, and quantified every single type of light we could possibly interact with.
All right, the final stretch, Section 5, D65, simulating the sun.
Let's see how this all builds together. Within that D series of illuminants, one stands head and shoulders above the rest as the ultimate industry standard. The CIE positions illuminant D65 as the mathematical representation of average midday daylight in Western and Northern Europe, which, by the way, combines both direct sunlight and the diffuse light of a clear sky. It sits at a correlated color temperature of right around 6,500 Kelvin. The CIE essentially dictates that D65 is the go-to for all colorimetric calculations that need representative daylight. This right here, this is the perfect mathematical sun. But here is where the science gets incredibly ironic and honestly kind of funny. Despite perfectly mapping out this ideal average daylight on paper, there are 0 actual D65 light sources in existence. You literally cannot buy a perfect D65 bulb. There are only simulators. Because the sun's relative spectral power distribution is so insanely complex, especially when you get into the ultraviolet region, humanity is just left trying to build artificial sources that get as close as physically possible. Researchers measure their fake light sources and compare them to the published D65 spectrum. The quality of those simulators is then rigidly assessed using something called the CIE metamerism index, which is basically a scorecard for how well the fake light matches the mathematical ideal. I want to leave you with this incredible quote directly from the CIE's own technical report. At present, no artificial source is recommended to realize CIE standard illuminant D65 or any other illuminant D of different CCT. What a fascinating paradox. We've measured the wild extremes of daylight. We know exactly how daylight intensity varies daily, plunging from 120,000 lux at noon down to a fraction of a lux at dusk. We've mathematically mapped the perfect average midday sun to guarantee perfect global color consistency. And yet, we still can't build a single bulb that perfectly recreates it. So as we continue to chase the perfect light, it leaves us wondering, will human engineering ever truly replicate the chaotic brilliance of our sun, or is true daylight a force we can only ever simulate? Thank you so much for joining me on this explainer today, and keep learning.